Hello, my name is Leyton McCash and I am a student at Dundee and Angus College studying zoo animal behaviour and welfare. As part of this course, we had the opportunity to study one of the amazing species housed within Camperdown Wildlife Park and create a documentary based on how the behaviour changes after implementation of an enrichment project. I decided to study the red-handed tamarins at Camperdown, which are a species of primate. We will cover how these animals live in the wild and how they are cared for in captivity. We will also discuss the manifestation of uncharacteristic behaviours in free species and talk about the role of the zookeeper. We will begin with a small introduction into legislation and organisations which impact animal welfare. In 1964, animal welfare activist and author Ruth Harrison released a book called Animal Machines, which exposed the grim welfare conditions of farmed livestock and poultry after the beginning of the intensive farming movement. Partly in response to the release of Harrison's book, an investigation was launched by the UK government to look into the intensive care of farmed animals and was led by Professor Roger Bramble. In 1965, once the investigation was complete, Bramble's 5 freedoms were written up and stated that farmed animals must be able to stand up, lie down, turn around, stretch their limbs, and be able to groom all parts of their body. 14 years later, in 1979, another investigation was launched, fronted by Professor John Webster, a founding member of the UK Farm Animal Advisory Committee, which built upon Bramble's original concept, stating that both the physical and mental needs of animals must be considered, giving us the 5 freedoms we know today. The 5 freedoms are the freedom from hunger and thirst by giving access to fresh water and an appropriate diet, the freedom from discomfort by providing a suitable environment and shelter, the freedom from pain, injury, and disease with preventative treatments and quick diagnosis, the freedom to express natural behaviours by allowing sufficient space and materials to allow for expression of instinctual behaviours, and the freedom from fear and distress by ensuring the conditions and surroundings are suitable for the species. These 5 freedoms are the basis of the majority of animal welfare legislation internationally and is constantly being improved upon to ensure the welfare needs of animals are met. The Zoo Licensing Act 1981 is the main piece of legislation which governs zoos in the UK and was amended in 2002 to include laws and guidelines from the EC Zoos Directive 1999, which governs European zoos. This act requires all zoos to have a licence to operate and to maintain high standards of animal welfare. Records must also be kept under this act, and health and safety measures must be in place to protect staff, visitors, and animals. When amended with the EC Zoos Directive 1999, this meant that all zoos must be active in conservation, research, and educational projects. The Ballet Directive governs the transport of non-domestic animals between European zoos, which allows for easier movement of animals to different institutions. Being a part of the Ballet Directive allows zoos to exclusively import and export primates and to waive any isolation period as the animals have been examined prior to departure. Camperdown Wildlife Centre is a member of BIATSA, the British and Irish Association of Zoos and Aquaria, which was founded in 1966 and publishes advice and guidelines in the form of best practice guides for a huge range of species. The aim of BIATSA is to promote conservation, provide education to the public, to provide advice on high standards of welfare, and to give advice on legislation. Camperdown Wildlife Centre are also a member of IATSA, the European Association of Zoos and Aquaria, which was founded in 1988 and represents European zoos but has many British members. IATSA's main missions are to promote and coordinate wildlife conservation throughout Europe, promote education in particular to the environment, carry out research and conservation internationally, and to be involved in captive breeding and captive management initiatives. WAZA, the World Association of Zoos and Aquaria, also provide advice and guidelines and are charged with outlining conservation strategies worldwide, producing documentation relating to conservation, breeding, and specific information on aquatic species. WAZA has also developed a code of ethics which handles issues which range from contraception, euthanasia, and transport of animals. Zookeepers are responsible for general feeding and husbandry duties, preparing and presenting food, and cleaning and maintaining the enclosure. They are also tasked with being involved in research, conservation, and education, which can be done through involvement in enrichment projects, breeding programs, or educational talks. All information of the day's events must be recorded by the keeper, including animal behaviour, medical notes, body condition, and feeding and husbandry routine. Keepers will also have to administer medication to the animals, amongst many other potential tasks. All records must be kept and maintained in line with DEFRA policies. ZIMS is an electronic record system used by zoos internationally and is used extensively by zookeepers. ZIMS also provides the latest research on countless species in captivity, which is readily available for use by the keepers. A European studbook keeper is responsible for a certain species and is charged with collecting information on breeding programs throughout Europe. Studbook members will keep records to send to the European studbook keeper, who will provide an annual report based on the findings of the breeding program. The goal of this is to guarantee the genetic health of the population and to allow for healthy animals to be exchanged between members to aid in successful breeding programs and the conservation of the species. Indicators of good welfare in a captive environment are provision and presentation of an appropriate diet, a suitable environment that is designed to stimulate and to include enough space, shelters, and adequate heat and light. If the species in question would normally live in a family group in the wild, they should also be kept with other members of their species in captivity. Animals should also be in good physical condition, free from disease, and have the freedom to express normal behaviours. Indicators of poor welfare in a captive environment would be a poorly designed enclosure, inappropriate diet, lack of hygiene practices, lack of enrichment, expression of abnormal behaviours in the animals, or signs of disease or infestation in the animals. Here we see the Asian short-clawed otters playing in their enclosure, which is an example of a natural behaviour which is seen in the wild. Uncharacteristic behaviours are actions that would not be performed in the wild, or are wild behaviours which are performed excessively. Not all uncharacteristic behaviours are harmful, but are seen to have no function and are viewed as ways of coping with boredom or stress. We will discuss uncharacteristic behaviours for 3 different species. Asian short-clawed otters are a carnivorous species and can develop uncharacteristic behaviours due to stress, or a lack of space, or a lack of opportunity to perform natural behaviours in their environment. Examples of uncharacteristic behaviours in Asian short-clawed otters are pacing and neck rolling, which are the most common uncharacteristic behaviours in carnivores. They can also show begging and anticipatory behaviour when waiting to be fed. Although this is an unnatural behaviour, it has been theorised that this may improve welfare by increasing attentiveness and activity. The otters at Camperdown would beg together and would mouth each other, which is a sign of affection, and makes this activity a positive social experience for the group. The main uncharacteristic behaviour which giraffes develop is an oral stereotypy, which is caused by a lack of complex browsing devices or lack of browsing opportunities, leaving the giraffe unable to perform natural feeding behaviours. This can also develop due to a lack of space, as in the wild giraffes would travel large distances looking for food. Lack of these opportunities can lead to giraffes licking non-food items in the enclosure and can lead to eventual health complications. This can be remedied by providing feeding baskets that allow for the natural complex tongue movements giraffes naturally exhibit. Red-handed tamarins are an omnivorous species and can develop uncharacteristic behaviours due to a lack of foraging opportunities, and can also develop from poor enclosure design that does not allow for natural movements or adequate cover. This can lead to pacing, aggression, self-harm, rocking, over-grooming, or lethargy. These behaviours can be avoided by providing an environment that suits the physical activity of the tamarins, allowing them to run, climb, and jump through the trees. The enclosure should allow for natural foraging opportunities, and enrichment devices should be given to provide stimulation and to allow the tamarins to solve a problem or complete a task to gain their food. Hand-reared animals are more prone to developing uncharacteristic behaviours. In the case of chimpanzees, a study of the behavioural differences in mother-reared and hand-reared chimpanzees at Parco Natura Viva in Italy found that the hand-reared chimpanzees performed locomotory behaviours significantly less than the chimpanzees which were cared for by their mother. The hand-reared chimpanzees also showed more abnormal behaviours than their counterparts. Although human intervention may be necessary to ensure the survival of the infant, consideration must be taken to minimise human-animal interaction increase time spent with their own species during their development to decrease the likelihood of uncharacteristic behaviours developing. Red-handed tamarins are a species of New World monkey which reside exclusively in South America, in Guyana, Venezuela, French Guiana, Suriname, and northern Brazil. They are known for their bright red or gold hands, with this coloration also being speckled on their back. Red-handed tamarins have a very varied diet, but are mainly frugivorous and insectivorous. They will eat dozens of different fruits in their lifetime and will also eat other plant matter such as seeds, nuts, buds, shoots, and flowers. They are also known to hunt and are not picky and will go after a variety of insects, small mammals, reptiles, frogs, spiders, and snails. They hunt by grasping their prey and inflicting a singular bite to the head. The tamarin species have long canine teeth which allows them to be efficient hunters. Red-handed tamarins will also feed on gum, nectar, or sap from the inside of trees. In the wild, this is usually done during the dry season when fruit is scarce. Red-handed tamarins will spend around 60% of their day foraging for food, mostly looking for fruits, but will take any opportunity if it comes along. The red-handed tamarins at Camperdown are fed a varied and natural diet, which includes several different fruits and vegetables, alongside insects which are gut-loaded to provide more nutrition and include locusts, crickets, mealworms, and morio worms. Gum is also provided in the form of gum arabic, which provides essential fats, proteins, vitamins, and minerals to the diet. And they are also given a banana porridge, which is given to supplement extra calcium into the diet. Red-handed tamarins are also known to steal eggs in the wild, so a recommendation for a food that can be fed in captivity would be boiled eggs, as it is similar to something they would eat in the wild and is a very nutritious food containing fats, protein, and is rich in vitamins and minerals. The red-handed tamarins are fed multiple times a day to replicate the time they spend foraging in the wild, and fruits and vegetables are chopped up and spread throughout both the indoor and outdoor portions of the enclosure at various heights to allow the tamarins to replicate natural foraging behaviours. Insects are given live and are spread throughout the enclosure. This allows the tamarins to exhibit hunting behaviours, and the design of the enclosure allows the tamarins to do this at height and to browse through leaves using their forelimbs to get to hard-to-reach spots as they would in the wild. Gum is given in a hollowed out log and is suspended in the enclosure. This again allows for natural behaviours to be performed. A bowl is used for the porridge to ensure the tamarins receive the nutrition the porridge offers, and it would be messy otherwise. Bowls are usually used to ensure the animal receives the correct amount of food they need for the day in an easy to get to location. We had to record a welfare sheet for the 2 red-handed tamarins at Camperdown, and the categories we selected are as follows: a suitable diet, was there enough space and safe hiding places, are they housed away from predators, did the enclosure mimic the tamarin's natural environment, and veterinary care. We found that the red-handed tamarins at Camperdown were fed a varied and natural diet, and it was presented to encourage natural behaviours. There was plenty of space for both the tamarins in the indoor and outdoor sections of the enclosure, and the enclosure contained 2 hides in the indoor section, and the roof and trees allowed for hiding spots outside. The enclosure was not next to any predators, and they are housed next to 3 other primate species, including common marmosets, pygmy marmoset, and red-bellied lemurs. There were plenty of branches to allow free movement, and various enrichment devices are housed within the enclosure. The enclosure is naturalistic with plenty of branches and verticality, which suits the tamarins' arboreal lifestyle. The tamarins are also checked over by the keepers daily, and the keepers try to check the weight of the tamarins regularly. Weekly vet checks are scheduled to quickly spot for any signs of disease. I believe that the staff at Camperdown provide a good standard of welfare, as the red-handed tamarins are able to express many wild behaviours and are given a stimulating environment through enrichment, enclosure design, and food presentation methods. They are housed next to other primates which they can investigate and interact with, and the knowledgeable keepers check them daily, and they are also checked regularly by a vet to ensure high standards of care. After researching and watching the red-handed tamarins and performing 3 pre-enrichment ethograms, we decided to focus our enrichment on promoting natural foraging behaviours in an arboreal setting that involved their favourite food locusts on request of the keepers. In the end, we decided to try out multiple enrichment items to promote these behaviours, but we will only focus on 2 here. We designed a wooden frame with a solid base that would have a bottle suspended in the middle, and the frame would be hung up in the enclosure. The idea behind it being the locusts would be placed securely in the bottle, and the tamarins would have to manipulate the bottle to get the locusts out. We also used hollow perforated balls, which were practice cricket balls. The cricket balls were stuffed with fruit, with some of the fruit poking out from the openings and some being encased within the ball. The balls were hung from the branches in the indoor enclosure. Both these items were used to increase foraging overall, the time spent foraging, allow foraging to happen at height in the branches, and to allow the red-handed tamarins to use their hands to gain food, and hopefully to stimulate them as they must complete a task to gain their food. The tamarins were interested in investigating the bottle frame as it went into the enclosure, but waited until we had left to begin interacting with it. One of the tamarins was interested immediately, whilst the other was more interested in the camera that we had placed blocking any footage we had hoped to gain. But this shows just how curious the species they are, and they will investigate anything new that goes into their enclosure. He eventually worked up the courage later to give it a try after the other tamarin had gained his 2 locusts. Interestingly, he left 2 locusts for his enclosure mate. Food sharing is prevalent in this species in the wild, so I'm curious if that was the case here. We also saw them hang upside down to manipulate the bottle, which is a movement seen more in the wild as they forage. Our trail camera also captured the bottle frame being used later at night, which showed it kept our interest, and it got numerous interactions throughout the day and throughout the night, as did the camera. The tamarins were also interested in the fruit that was in the hollow balls, despite there being fruit which was easier to gain in the enclosure, and we got lots of different interactions with these. The tamarins would use their hands to pull fruit out or to reach inside, and they would even use their teeth to yank the fruit out or lick the fruit that was poking out of the holes. They were interested for around 20 minutes until they retired to their hide to sleep. We carried out 6 ethograms in total, 3 being before the enrichment and 3 during. The hypothesis was that foraging, locomotion, and investigatory behaviours would increase after the enrichment was placed in the enclosure. Here are the results. I expected investigatory behaviours to increase as different enrichment items went in. Although they did investigate the enrichment, they were mostly confident in tackling the task that the enrichment offered, and investigatory behaviour was actually lower at 41 post-enrichment and 56 pre-enrichment. Red-handed tamarins are inquisitive animals and enjoy looking for their neighbours, for visitors and keepers as they walk by and anything new to them. And as you see, they love the camera, so are very exploratory and curious by nature. I was surprised that locomotion was lower by a large margin, from 284 pre-enrichment to 140 post-enrichment. A factor can be that they spent less time moving around or used more measured movements as they were using the enrichment. Another factor was the weather. It was raining in the week of the second post-enrichment ethogram, and the third ethogram was recorded in cold weather. The red-handed tamarins are from a warmer climate and preferred to stay inside when it was either raining or too cold. In the second week, the tamarins interacted with the enrichment for 20 minutes, but then retired away to their hide together for the rest of the ethogram, which led to lower numbers in the locomotion category. Our first post-enrichment ethogram also had to be cut 10 minutes short due to time constraints, which may have led to lower numbers overall. Although this was the case, we still saw an increase in foraging behaviour during our time spent watching the tamarins. Foraging behaviour increased slightly from 27 to 36, which is what we were looking to achieve, and a significant amount of time was spent using the enrichment. Overall, I feel like the project went well and it got lots of interaction, and we achieved our goal in increasing the amount of times they foraged and the total time they spent foraging in a stimulating manner. If I were to do it again, I would have fixed the lid of the bottle more securely, as the tamarins removed it quickly and bypassed it to get more easy access to the locusts. I would have also added more beams onto the frame and made it slightly bigger just to allow for more climbing opportunities for the tamarins. I would just like to say a big thank you to the staff at Camperdown and my college lecturers for their support throughout this process. I had a great time researching these amazing animals, and I hope you enjoyed watching. Thank you, and goodbye.